In this podcast, we're exploring the basis of how currents flow around electrical circuits. So, Ben, what actually is a current?
Well, electric current is the flow of charge. That's normally in the form of electrons flowing through something, for example, a wire. It's pushed along by something that will produce a voltage, something like a battery.
So is it similar to how water flows through a pipe?
It can help to think of it like that, but one big difference is that if you make a hole in a wire, the electrons won't fall out like water would from a pipe.
And why is that?
Well, electrons are negatively charged, and the atomic nuclei in the wire are positively charged, so they are attracted to one another very strongly. This means that you can't lose many electrons from a wire before it becomes strongly positively charged and will attract them back again.
But if the electrons are so strongly attracted to the nuclei, how can the electrons move to make the electric current flow in the first place?
Well, one electron can easily move along a wire as long as there's always another one moving to take its place. And the second electron can only move if there's a third one to take its place, etc. This only works if you join up the two ends.
So what you get is the electrons flowing in a sort of giant circle around this circuit.
Yes, that's right. We call it an electric circuit. Electric current will only flow if you complete the circuit. So if you put a lamp on your wire, it can only light up if there is a complete circuit.
And what's a short circuit then?
Well, electric current will tend to follow the easiest path through a circuit. So if you give it two choices, one to flow through a lamp and the other one just to flow through a wire, most of it will flow through the easiest route, the one through the wire. So the bulb won't light up and you have a circuit with lots of current, but none of it is going where you want it to.
So if I want to make a circuit that works, what do I have to check for?
Well, for a simple one, make sure that you have something to push the current around that produces a voltage, like a battery, that there is a route in your circuit back to the battery, so the circuit is complete, and that there are no other routes for the electric current to take which would be easier.
So it's the battery that's pushing the current around the circuit. Does it go in one particular direction then?
Well, yes, this is an interesting one, actually. The thing that's actually moving is the electrons, and they go from what we call the negative end to what we call the positive end. But when scientists were first studying current, they didn't know what was going on, and they talked about it flowing from positive to negative. Confusingly, the convention got stuck like that.
So what you're saying is that these scientists had a 50-50 chance to get it right, and they chose the wrong way to describe the flow of current.
Well, sort of. When you're actually studying a circuit, you can't really see what's flowing where anyway. So all you have to remember is that we say current flows from positive to negative, and there's no problem.
How do we actually measure the flow of current?
Electric current is a flow of electric charge, and charge is measured in coulombs. If 1 coulomb of charge flows past a point every second, we call that a current of 1 amp. A larger current involves more charge flowing past every second, and so could be several amps.
And how do we actually measure the amount of current, the amount of charge going past that point in a second?
Well, rather unimaginatively, the machine for measuring current, and therefore amps, is called an amp meter, which is often shortened to ammeter because it's easier to say.
And so if you were building a circuit, where would you put the ammeter in the circuit to measure the amount of current that was going around?
Well, it will measure the amount of current flowing through the ammeter itself, so it needs to be in series in your circuit so that the current will flow through it.
And what does in series mean?
Well, for example, if you have two components in a circuit, there are two basic ways of arranging them, in series or in parallel. If they are in series, they are one after another, so all of the current has to flow through one and then through the other.
And what about if they were in parallel?
Well, then they're arranged so that the current splits into two, and some flows through one component and the rest flows through the other. The two streams then join up again afterwards. So in a parallel part of the circuit, the total amount of current will equal the current in the circuit before it split.
So if I had two light bulbs connected in parallel, and they've each got 1 amp flowing through them, what will the total current coming out of the battery be?
Well, it will be the sum of all the currents flowing in parallel, so 2 times 1 amp is 2 amp.
So Ben, first of all, tell us, what is voltage?
Well, to make things move, you generally have to push them. Electrons are just the same, but they're really tiny, so you couldn't possibly push them individually. But when a battery applies a voltage, it makes one side of the circuit slightly negative and the other slightly positive. Because electrons have a negative charge, they will then be pushed from the negative side towards the positive, and the higher the voltage, the stronger the push.
So the larger the voltage that I apply, the harder I'm pushing. So does that mean the more current is going to flow?
Yes, that's right. If nothing else changes, then that's right. You can produce voltages, also known as potential differences, chemically, using batteries or a cell, magnetically in a generator, for example, or even by rubbing a balloon on your head.
What's a cell?
Well, you probably know it as a battery, but technically a battery is more than one cell attached together. There are various different types of cell which produce different voltages. The most common disposable cells produce about 1.5 volts, and the most common rechargeable cells produce about 1.2 volts.
Why would you want to connect more than one of them together?
Well, if you want more than 1.5 volts, you'll have to use more than one cell in series, and then the total voltage, or potential difference, will be the sum of all of the voltages in all of the cells.
And what does that term potential difference actually mean?
Well, really, it is just another name for voltage. You can think of a battery as giving the electrons at the negative end potential energy. They will then be attracted to the positive end of the battery, so as they flow through the circuit, for example, if they go through two light bulbs, they release that potential energy. The bigger the difference in potential, the more the electric current will be pushed around the circuit.
So those two electric light bulbs, if you have them connected in series, what happens to the voltage?
Well, if a current flows through two lamps in series, the charges flowing will use up some of their potential energy, that's their voltage, passing through the first lamp. So then all that's left will go through the second lamp.
So the voltage across each lamp, will that be less than the total?
Yes, it will, and the lamps will be dimmer, but the sum of all the voltages across the two lamps will be the same as the total voltage produced by the battery. But if you put your components in parallel, then the total voltage must be the same as the voltage across each component.
So the lamps would be just as bright as if they were there on their own?
Yes, that's right.
And how would I measure the voltage across them?
Well, voltage is measured in volts, and unsurprisingly, a device for measuring voltage is known as a voltmeter. If you put the voltmeter in parallel, then the voltage across the voltmeter should be the same as the voltage across a component, so you'll get the right reading.
And what happens as the voltage gets bigger? In other words, if you have a very large voltage?
Well, although electrons don't normally escape a wire because they're so well attracted to the nuclei, if the voltage is large enough, then some can actually jump out of the wire and current can flow through the air. When this happens, the air gets very hot and expands very quickly, which makes a noise, ranging from a small crack or to a thunderclap, depending on the size of the spark, and the air will give out some of the energy it's given in the form of light.